Ladies and gentlemen, good morning. In the VTT Tech Talks, today we have a guest that will share with us his experience in high-tech SMEs, founder of Simic, Ayat, and now Athlos, OU, Konstantinos Spartiotis. Please, Konstantinos, the floor is yours.
Thank you, Philip. Hello, everyone. Good morning. 25 years ago, I set foot for the first time into the Micronova facility. So it is a real pleasure for me to be here today talking to you. Basically, almost all familiar faces. The title of my talk is inspired by this 25-year-long career so far in the high-tech sector and particularly in Finland. So it's still installing the third version, but we will see how that proceeds in the near future. I wanted to create a context for this presentation, and I found a statistic that is a bit alarming, so it's a good thing to put it up there as a guideline to start with. So apparently, not just in Finland, but on a European level, about 3% of startup companies, not just high-tech, in general, startup companies reach the scale-up phase, which is 20% growth in 3 consecutive years. And another alarming statistic is 40% only of European startups make it through the first 7 years of their life. So with that context, let me start from the beginning. The birth of a technology. In 92-93, when it all started for me and a few other players in this market of radiation imaging detectors, I was coming out of CERN fresh with a PhD. So back then it was the Large Electron-Positron Collider, and this is a graphic of me next to our detector we had at CERN. And of course, like any young scientist, I was full of dreams and visions. At the same time, there were a few very impressive developments in the field of radiation imaging. I distinctly remember Radir. They were trying to actually create the first cadmium telluride intraoral sensor. Remember, year 1993. That was pretty breakthrough technology they were trying to develop back then. A young startup by the name Detexo Technology was just being founded with the aim to create silicon strip detectors for CERN. I remember traveling to CERN with Eero and Mikka. Of course, Detexo Technology today is one of the most successful companies, high-tech companies in Finland, albeit with much of their manufacturing taking place outside Finland. At the same time, we had the Medipix collaboration making its first infancy baby steps. And finally, the young scientist, Konstantinos, founded his first company, Simic, or in Finnish, Simage, with the aim to create the first of its kind high pixel density charge integration detector utilizing either silicon detectors or cadmium telluride, cadmium zinc telluride. So in the early 1990s, Finland, as we probably all remember, was undergoing a rapid transition, and young startups were facing a lot of challenges. In my case, and I would like to share with you some of those challenges and difficulties that I went through, can be summarized as follows. When you start a company in the high-tech sector, the first thing you need is to focus on, especially when you are at a young stage, when I was at that moment, who is your mentor and what is going to be your strategy? Because there is a lot of ideas and a lot of good concepts out there, but putting together the strategy to bring it to the market is of paramount importance. So, strategy. Of course, equally important is how do you get funded? And that led me very fast to business angels, and I have deliberately put angels into quotes because in many cases this is a misnomer. Maybe you can call them the great white sharks. So I have made in my life so far quite an amount of them, and I had good and bad memories. So the one thing I learned is that the market never sleeps, hardly forgives, but never forgets. So let's start with funding. You want to make a company in the high-tech sector. 98% of the companies that are startup in that area need funding. So I could pull out a bunch of graphs that already published, but I thought to create my own artist impression of my experience and transfer that to you. On the horizontal axis, you have the story that you build up, your business plan, and you're trying to sell to your investors. And you have to decide when you ask for money, what is the return on investment that you are promising over typically a period of 5 years. On the vertical axis, you have the probability of achieving to close a funding deal. Well, to my surprise, I found out that it is much less likely that you will actually get funding if you promise a return of a factor of 2 or 4 over a reasonable amount of time. Typically, business angels want to see a potential that is more counted in the tens. And therefore, that curve is quite a challenge for an entrepreneur because you have to know that what you promise stays there. That was a challenge for me, and I tried to fight against it. Otherwise, it will come to haunt you like a boomerang in the future. Not overpromise at the start of your company. The second thing is, how do you actually go from your idea to the market and create positive cash flow, specifically in the electronics and components industry? That comes a lot back down to the mentoring and who is behind spiritual father, if you wish, the strategies behind the young entrepreneurs. So in the case of Simage, which was Entrepreneurship version 1.0, the idea based on the mentors I had at that time was get a smart idea, which was that we make the first ever in the world direct conversion, high pixel density, charge integration imaging device, make prototypes, patent the whole thing, sell the patents, and then let the buyer worry how to make use of it. In other words, come to the point that you create so much value into the patents and the prototyping that then the buyer of your technology is the one to bring it to the market. But this model, unfortunately, does not work in the electronics and components industry. It may work very well in some other sectors. For example, I'll give you an example, pharmaceuticals. You find the cure for cancer in a well-established molecule. You go through clinical trials level 1. You may well sell your company for $100 million or euros, and you're done. But in the electronics and components industry, it doesn't work like that. The Simage patents, so we followed this strategy. We came to the prototype, we made the patents, and indeed we managed to achieve at least part of the target, which was to sell the patents. I can rather proudly say that most of them were then later on sold to Siemens, and most of them were considered cutting edge at that time. So job done from the scientific point of view, but not from the entrepreneurial and cash flow generation point of view. That work, I have to say, led to some breakthrough results, including the first of its kind digital mammography system based on silicon pixel detectors, and the first of its kind intraoral sensor based on multi-chip module on silicon again. All that was encompassed in a PhD by my good friend Tom Schulman. Such PhD is to this day used as a benchmark and as a reference to anyone who wants to enter this kind of technology. But did we reach the market? That's the big question. The answer is no, and I have no fear or remorse to state that. We went as far as making the prototypes, and then when the time was when we realized that we now need to go to the market, it was a bit too late, and the production process and the manufacturing was not up to date and up to speed. So I underline and highlight production processes because when I realized it's time now to put this to use, it was a bit too late. But as you can see, the images that are 25 years old made with these technologies were of superb quality and importance. Lessons learned. So in Entrepreneurship version 1.0, I learned a few valuable lessons which helped me lead the next version of Entrepreneurship, version 2.0, to success between 2001 and 2016. Decision-making process. So I modified, I trimmed and tuned my decision-making process when I set up IAT. First, you have to find out what is your core technology. And I decided at that moment, what is the core technology? It's all the manufacturing, and it's not the patents or general speaking IPR. So it's the core technology. In the case of IAT, was manufacturing, and it was the in-depth knowledge of the electronics design and the software. Then you have to realize what's your added value in the market. What is that you are doing that is done better in your company, more efficiently and cheaper than others do it in the market. Once you do that, you find the right application. You make sure you have the infrastructure and the manufacturing available at your disposal. And to that effect, I raised my hands and saw this Micronova facility where I have been for 25 years. And then you come to what I realized was the most critical part, which is how do you get your product to the market channels. When you do that, you find out if you are priced competitively or not. And competitiveness means the ratio of the value you add with the denominator of the transfer price. It doesn't have to be that your product is the cheapest in the market. The ratio of your added value as perceived by the market divided by the transfer price has to be competitive. If the answer is yes, off you go. If the answer is no, you go back and you trim your model, you look for another application. Remember, in CMADS, I started with mammography. That was a big mistake, because later I found out that to get a digital mammography system in the market, you need 100 million euros maybe just for the clinical trials. So in the case of IAT, we started with much simpler applications to the market. If it still doesn't work, then you go and you reshuffle your core technology, added value, and application until you find a winning combination. The second lesson I learned is how to survive what I called the cash flow fist dive. So again, don't try to find this in any publication. This is Dr. Konstantinos' graphics. So the fist dive represents the cash in the company on the horizontal axis versus the probability of raising additional capital. That's another thing. You might now say, oh yeah, it's obvious. But again, I found that in Siemens time, the hard way. It goes like that. The more money you have, the more likely it is you will get more money. You might say, well, if you have money, you don't need more money. Well, that's the point. So you have to raise enough money in the beginning when you raise your capital for your new company. And as the cash in the company reduces, and of course it will reduce because in the beginning you're spending money to make your products, you reach a point which I call the deep impact point, where you have minimal cash and hopefully you have your first product. At that point, you have to survive that deep impact point, and that's what I call you need to have generated and to have enough of a cash airbag cushion to help you survive that deep impact point in your cash flow. And after that, you go into the market and you slowly raise your cash position and your probability to raise additional money. The next thing is how to survive the cash flow double dip. Again, not a graph of science, but a graph to transfer to you the experience I've lived in how to make IAT survive and succeed. You start with your initial capital. This time, on the horizontal axis, I have time, calendar time. Days and weeks and months go by. On the vertical, I have the cash in the company. So you start with the capital, then you go again to the minimum point we saw in the previous graph, which is when your product is hopefully ready and you start your revenues. So then you increase your revenues, but then you close that big deal and you really have to go into investment, CapEx, equipment, facility, and last but not least, a very big inventory. So then suddenly you go down on a steep slope that can be very slippery. And that is the working capital and investment scenario. So that's your second dip in your cash flow when you have your first product. Of course, if you survive that, you go into healthy organic growth. Again, you need a cash airbag. So the lesson I took out from Entrepreneurship version 1.0 and I carried forward to Ayat, be extremely careful how you handle your cash. The third thing is time to market with your products versus the size of the original equipment manufacturer OEM client that you're trying to attract. The bigger the client and the more recognized, the longer it's going to take you to close that deal and go to the market. Number one. Number two, your products are not mature just in the beginning of this process. So most of your technology issues are going to happen in the early phases. So imagine you launch with a big company first, that you reverse the order, so you spend a lot of time to go to the market because they have so strict specifications, so high quality standards, and then on top of that you start having field returns because of course it is impossible to have a product that is 100% ready before you launch. So that lesson which I followed says start with a smaller fish while you go for the big deal. Next is the price war, which I immediately faced with Ayat. So here it's the calendar year from about 2003 to 2016, and the vertical axis is price in euros. Sorry, I forgot to put euros here. The blue curve is the sensor we developed in Ayat. The orange curve is the competing sensor based on non-direct conversion. There was a very big differential in the beginning, which I tried to close. And you try to close it by reducing your cost, improving your production, becoming more productive and efficient. I managed to close the scissors, the gap, but you can never actually completely beat competition price-wise with this technology, simply because the phosphors basically cost nothing, and cadmium telluride or silicon cost a lot more than nothing. So you can never actually make those match. So that's a war you cannot win. And the lesson I took from that is fight not to be the cheapest in the market, but fight to sell what is the value proposition you're having. Therefore, the pyramid of success goes as that, like follows. You start with an idea concept, and I have no, I don't mean any offense to all the wonderful ideas of all the wonderful young people. We need a lot of ideas and we need them all the time. But there's a lot more of good ideas and good concepts than successful startup companies. So that goes to the bottom. You need a good idea, but you haven't achieved anything yet. The next big thing is you need to do your fundraising, and you need to do this in a way that you don't lose control of your company. So using my new term, the great white sharks are there to give you a bunch of money, but then to take the company from you, essentially. So you need to survive that. Then you start your research and development, which you need to complete in a timely fashion. It cannot go on forever, for 10 years or 20 years. And then, finally, what I call the first point of opening the first bottle of champagne is when you get your first deal of recurrent revenue. That is a big moment because it signifies that you are in the market in a way that the market is trusting you. So then you have to create the market forces to continue the growth, and you have to deal with the problems in a swift and decisive way, and finally you are successful if you generate net cash for your company. So what were some of the Ayat successes in this endeavor, which I do consider one of the probably more successful companies in Finland for its size and technology sector where it was? First of all, we were the first company to manage to retrofit dental systems that were based on film. So that's the pull force. We went out to the market, we went to Korea, and we took out the film, and hundreds of dental systems in dental offices became digital using the cadmium telluride technology. Never done before. In certain places, so much was the excitement about the superb quality of the direct conversion sensor that clients would actually buy a digital system with supposedly a digital sensor that was of high quality, but they would remove the sensor to put in the IAT sensor. Think about that. So that was another pull force. So we're talking about 1,000 systems worldwide that we started by doing that. And with that created the initial revenue and the initial cash flow. We also launched our own dental system with our own brand name, which further created agitation in the market and finally convinced the big players that this is a technology they cannot just go over. And of course, the big pride of mine in my career is closing 2 mega deals with Yoshida and later with Sirona. Yoshida is the #1 imaging dental system supplier in Japan, and Sirona, today it's Sirona Dentsply, #1 or one of the top 3, I would say, in the planet, worldwide. So imagine that, starting from retrofitting dental systems in small Korean dental offices to closing a mega deal with the world's leaders of a technology that was completely unknown just 2 or 3 years earlier. So that was a success that I would call monumental. We scratched the surface of industrial sales, but we scratched it in a way that left its mark. The Valka product, so here you see the complete production line that Valka is building, is just an example where you have fish fillet, salmon or white fish flying through the production line before packing, and you would have an IAT sensor, a cadmium telluride sensor, identifying if there is any bones in the fillet, which then the robots would remove automatically before it's being packed. Tremendous achievement also because of the conditions around that system. And then a completely different application, you have a system for inspecting the integrity of the welds in pipes in the oil and gas industry. Again, a fantastic success. Now, I said all of these things took place here in Micronova, but there is a tangible risk, there is a real risk, as we have seen already, that manufacturing, specifically of electronic components, is moving away from Finland. And where to? Well, for sure in Korea, for sure in China, and yes, it's also going to Japan and the United States. So there is 3 factors that contribute to that. #1, labor cost. #2, cost of building own facility. #3 is more specialized and less generally known, but applies for this particular industry, the cost of packing or of assembling the radiation imaging devices. So it's not a secret, and this slide is not science or artist's impression. This is a real OECD data for Finland from 2016. Unfortunately for all of us, and I remind the audience I'm also a Finn, Finnish productivity increased rapidly. We were world champions between 97 and about 2006, only to take a dive after that and stalemate after that. And the red curve, which is what I'm interested, is the productivity of manufacturing sector. That's not good news. Well, productivity is you put what is your output per unit input. So we need to look at the unit labor. The labor cost in Finland followed the same trend. So higher salaries, or the rate of increase of salaries, continued throughout from 2000 until 2014, exceeding the last 3 years just about anyone in our neighborhood and the average in the European Union. So you can imagine, if we exceeded the denominator, the cost of the output, that means that we are getting paid more, but we are producing less. That's the stalemate and the decline in the productivity. So we cannot be happy with that, and I may become now a little bit unpopular, or one might say this is cliché, but here is a slide I have prepared about the changes I would like to see in my own personal humble opinion. I would like to say to everyone, specifically to the workforce of high-tech industry for startups and mid-sized companies, let's go back to the early 90s, where people consider it a privilege they have to fight for when they would work for a high-tech company. It means I would like to see workforce commitment raising to a new level, the ethic and the commitment raising to a new level, more stress tolerance. Let me not go to statistics in that. There is, I don't know how many orders of magnitude more burnouts recently than it was in the early 90s, but I don't think people were living much more comfortable back then. And then combining those things together, we need to contribute in increasing the productivity in Finland. The second point I want to say is that, and I know it probably doesn't matter, but I'm here to say what, in my, again, humble opinion is the case. It is suicidal that politicians in Finland reduce the budget for innovation and technology, and on the other hand, they maintain an overly socialistic welfare system. Over the years, we have seen the budget of VTT being cut, and no, I have not been told by VTT to say any of that. This is my own honest opinion. The budget of facilities like Micronova being cut, the budget of Tekes being cut, and therefore there is less money to be spent on innovation, there is less momentum for the startups and the early stage high-tech companies. The cost of the facility is the second point, and we need to, in my opinion, come to a model where what we have available we need to utilize better, contribute to its maintenance, and by higher utilization rate, increase productivity. And that also goes for Micronova, and it goes also for other facilities in Finland. And the last point to actually get out of this slump in the productivity is the flip chip technology. That's specifically for the radiation detectors. The current technology used by companies like IAT, X-Counter, Advacam, my new company Athlos, it's just too expensive. So in order for the direct conversion technology to become more competitive versus indirect conversion technology, we have to find alternatives to the expensive production technology. That means, for example, we need to find a cheap and efficient solution with isotropic conductive adhesives, anisotropic conductive adhesives, magnetically aligned conductive adhesives, and physical vapor deposition. Finally, there is over-the-top advanced technologies, including fusion of materials with homogeneous substrates. So, ladies and gentlemen, I think I have another 5 minutes or more. I don't know how much of time I have taken so far. That brings me to Athlos. So on the backdrop of the success of IAT and having generated more than 70 million euros of revenue selling these direct technology detectors, I founded Athlos in 2017 in April. Athlos comes from the ancient Greek word, which is also used for athletes and means basically achieving something great and of great importance. What is Athlos aiming to do is to make direct conversion detectors that are smarter, faster, and cheaper, that are patent protected to help with international competition, and maintain production in Finland through shared resources, including facilities that are utilized by several companies to reduce cost, utilizing a global established network of partners, not starting from scratch, but we have a global network of partners, and increasing productivity. If we go through the current and what Athlos is trying to achieve, intending to achieve in the future, is we're going to shift a lot of the functionality from the peripherals on the sensor inside the application-specific integrated circuit. By doing so, we reduce the complexity and we reduce the time to market. And of course, reducing the cost. The second thing is what I call the red devil. I always like to give names to new inventions. So the red devil is mercuric iodide, which you see here. This is a material that in itself is not novel. There has been research about mercuric iodide for the last 10-15 years. The last, I would say, 5 to 7 years, actually, there has been a slowdown in the research and development. But recently, there has been some developments and breakthroughs that make this material stable enough over time. The trick here is what? Is that you can deposit the red devil, the mercuric iodide, with physical vapor deposition in polycrystalline form directly onto your substrate. This reduces your cost by a factor of 5. This will make it as price competitive, if not more price competitive, than the indirect conversion competition. So you could have the holy grail for the price of a normal cup, if that works. Latest development, and I don't know how many of you have heard about that, so I thought to bring you something that maybe you have not heard, because I think the previous slides maybe you have heard, is perovskites. So raise your hands, who has heard about perovskites? Okay, so there is half the people have heard, haven't heard. This is something I have come across now the last 6 months. This technology comes from the solar cell panels, and about 5 years ago they managed to go and build this material, the solid state detectors in solid state and in a environment that is stable and fast. One example is methylammonium lead iodide, another one with bromium. So why this is exciting? Number one, it has absorption similar or better to cadmium telluride. Number two, it has a mu-tau product that is similar or better to cadmium telluride or cadmium zinc telluride. Number three, and this is the big excitement for me, in theory, you can grow this directly onto the substrate, which can be your readout. So you don't have physical vapor deposition, but you can actually homogeneously integrate that material directly onto your readout, i.e. you don't need any bump bonding, you don't need any flip chip bonding. This is a direct, in a way, deposition with a new material. And again, what makes this super exciting is that based on the literature, you can even make this for $1 per cubic centimeter. Do the math. This will beat every competition price-wise and performance-wise if it works. This is still at its infancy. This is very hot topic in the science community as we speak. The last publications have come out just like 1 or 2 months ago. The other thing that Athlos is going to do is go wireless. And we're going to go wireless first with the intraoral sensor, creating a workflow that is much more efficient today in the dental office and is more comfortable for the patient and more safe. Based on our market research, there is too many retakes in the United States, for example, just because of the cable and the uncomfortableness of the existing wired sensor. In order to develop wireless technology, you need to have electronics that are next generation, very low power consumption. You need to have batteries that are very compact with enough capacity. You need to have RF channels that are transmitting with enough bandwidth without eating too much power. And we're going to do all of that for starting with the intraoral sensor. And here is again a description. You can have therefore the same sensor paired individually to different workstations. You can have the sensor changing rooms, and it all becomes very, very simple. This technology, wireless, is in a different level, a different platform. It's not material science, it's not cadmium telluride, silicon. It applies to everything. So I want to emphasize how important is the web of relationships. I imagine this as a spider net, and your big prize, your grand prize, is the markets. You want to get the markets. And you need to realize that you're just one little part of that spider web. The web of relationship is extremely important. For a radiation imaging company operating out of Finland, you have to have these relationships in place, and you have to play your cards correctly. And you have to work together with your material suppliers, be it cadmium telluride, mercuric iodide. You have to make joint ventures and give in potentially some part of your control and power in order, however, to get access to the markets. You have to work with your dental OEMs. You may even have to work with some people that you may consider to be your competitors, because that would accelerate your entry to the market. So this is extremely important, to know oneself in this web of relationships and to make use of that. To summarize, Athlos intends to introduce completely wireless wearable technology starting from the intraoral sensors and thus contributing to and simplifying workflow in the dental offices, increasing comfort of the patient and safety. Introduce a completely new generation of CMOSes with logic never seen before, simplifying the peripheral electronics of today's sensors and also simplifying the manufacturing of those sensors, therefore bringing the price down while increasing productivity. Introduce direct conversion panels to be part of the revolution that is going on worldwide, which goes from 2D to 3D. We believe that in 10 years from now, there's going to be very little of two-dimensional imaging done. It's all going to be three-dimensional. If you want to be part of that, you need to have cheap and good flat panels. So we want to be the first to bring direct conversion panels at a cost very similar to that of indirect conversion panels. And we will put emphasis on collaboration, international relationships, and what I call the web of relationships. So, with all that said, one can just gaze into the future and wonder, yes, but would any of that be made in Finland, or are we going to be doing a technology transfer to I don't know where? China, Japan, Korea. So 25 years ago, I set foot in this facility, and all of the development until from that moment has been in this facility and all the manufacturing. 25 years later, I'm staring into the future and I'm telling you that as far as I'm concerned, and if I can help it, you bet we're going to do this stuff in Finland. Thank you.
Thank you, Konstantinos. Very, very exciting talk. I'm sure we have questions in the audience. One here.
What happened to Ayat and why did you leave Ayat?
Actually, a lot of my Ayat colleagues are here. Ayat is a successful company. I left a year ago. Ayat was acquired in 2009 by a Swedish company, and I stayed in Ayat for an additional 7 years. But it is a book that has been written many times when you're acquired by another company, and you will no longer control your own fate or your own future. Slowly but gradually, you come to a point that you need to make your next move. For many people, this thing happens within a year. For other people, 2 years. In my case, I stayed 7 years in Ayat. I increased the revenue 3 times from what it was, and a year ago, it was time for me to move on. I mean, I shouldn't go into the details. It's a book that has not been written for the first time for my case. But if you want to know more, I can talk to you in private afterwards.
Other questions? Where is the headquarters are in Espoo, right?
My headquarters are in Espoo. Well, we don't, as I said, all the part of the presentation that concerns Athlos is installing, right? It's the first slide. It's still not downloaded completely yet. We will be up and live in a few months from now, but things are looking extremely promising, and I would say emphasis put in the openness I have taken now in this third version of entrepreneurship to the international states of relationships to the companies that I want to work with. Of course, raising capital is very important. I have been active on doing that, taking the lessons from first and second version. And you will see Athlos booming in the next few months.
Okay, exciting to hear about new products, a new company. Last opportunity for a question.
So you mentioned that you would even be able to partner with some of your competitors, and understanding that you have one of the great achievements of this version 2 was to actually ramp up this production. So from the prototypes you were able actually to produce products in the larger amounts. So are you going now with Athlos and to reinvent the wheel, or could you see yourself partnering with version 2.0?
So that's a very good question, and again, it's a little bit of a political question. But I will say this. I have learned from version 1 to version 2. I succeeded in version 2. In version 3, I want to succeed 3-4 times more than I succeeded in version 2. I close no doors, and for me, there is no collaborations and no partnerships that are not possible. I believe the world market and the world stage is big enough for several of the versions to coexist, and definitely I don't plan to reinvent the wheel. I intend to succeed a lot faster and a lot more than in version 2. So the answer is a big fat yes. Cooperation and collaboration, when it leads to a mutual and a win-win deal, is almost always welcomed.
I wonder if we will have a question on productivity slide.
Yeah. Anyone want to talk about reducing the labor cost or?
So how could we do together to have manufacturing in Finland? What is needed?
That's also a very good question and a very difficult one. I think, well, I know the interest of your company, and I think your general principle of sharing a facility and having a facility, I think I am in line with that. How to do it, how to arrive there is maybe where I would probably tune myself and treat myself a little bit different approach to what your company has taken so far. But let's put it this way. If we look at the Micronova facility, I think this is a good example of a facility that has enormous potential and opportunities. It has been the birthplace of a few companies, including detection technology, including IAT, including Advacam, Rockley Photonics. It's still underused. It still doesn't meet its budget expectations. So what we have to say, and I don't have all the answer to your question, but more co-utilization, more co-sharing of equipment. Like you have one flip chip bonder, why do you need to have 3 flip chip bonders and 3 operators when one can work 24 hours a day, 7 days a week, and satisfy the needs of all 3 companies? And that's where the intricacies, the competition comes in place, you know, who wants to work with whom. But I believe we can do it. And I believe we can do it because I've spent half of my life in Korea and in Japan, and I see how those companies work with one another. I see how, I mean, in Korea, you would never choose the product or the services of a foreign company if there is a Korean company. But obviously, that question needs to be addressed in more meetings, which I know you are organizing, and I think the principle is there.
Thank you.
How do you see fundraising opportunities for this kind of specific technology in Finland, and what happens if you are not successful in the initial phases? You are talking about rather raising more money initially than less money. So where do you find that kind of investors who understand this type of technology?
Yes, so if you are a young entrepreneur, a young company that do not have yet credibility and reputation, it's a lot more difficult. Then almost inevitably you may fall in the teeth, and I will not say wings, in the teeth of the great white sharks. So you go to those guys and you would be raising money on the backdrop of big return promise. If you are already established credibility, my advice is go and get your money from the market. Preferably, if you want to keep control of your company, preferably avoid angels, and preferably avoid, if possible, institutional venture capitalists. Because VCs have a very professional and a very good way of approaching the business, but again, they pretty much do control your company from day one. Even if you take €500,000 from a VC, the shareholders agreement and the terms you have to enter are so enormous that you have very little control. So if you can make a joint venture or a partnership with a company, an industrial partner in the market to raise your initial capital, number one. Number two, you go and apply for money from Tekes or other public funding organizations in Finland. which despite the fact that they have also big budget cuts, if you have a good plan and if you have raised your seed capital, then they would usually help in this kind of situation. So, in order of preference, I would say, try to keep the control of your company. Therefore, try to get a joint venture or a deal with one of the industrial partners that you are targeting. After you do that, you have a business plan that you're able to present that is reliable and credible to, for example, take us another public organizations. 4, try to avoid fundraising from sources that will remove the control of your company.
Yes.
Just as a one follow-up questions for the previous question. So, trying to find funding from the industrial partner, do you see any issues that exit plans actually may come quite challenging?
I really love it. I get all these good questions. So you guys listen to my presentation. So Kai, that's another fantastic question. So yes, you don't lose the control of your company with all those clauses of good liver, bad liver, and this and that on the board of directors. But almost without a doubt, industrial partner will want to have some kind of exclusivity. But the market is huge. So if you have to give exclusivity for Korea or for Japan, and that someone is the number 1 or number 2 company in that geography, it's little evil for a lot of good. If you go and give exclusivity for your entire dental sector to the entire planet, then don't do it. This is the Korean sign, don't do it. But if a Korean company says, here's €1 million, but I will be the one selling in Korea, then you do it. So the answer is you have to negotiate. I didn't say it's easy. It's damn difficult. But if you succeed, you get away with a limited geographic and by application exclusivity that gives you your money without really losing the real potential.
Okay.
One more question about the facility and kind of how to make the production here or in a similar facility. So I mean, Micronova, what we are doing is basic research. Kind of students are learning how to do processing here. There is basic research, applied research, there is production. So how do you see these are fitting together? You said that this is underutilized, which is pretty much true. But how do you think that it could be best done to kind of combine these? Can they be done with the same tools, or do we have to have like a production line and a kind of a research lines separately?
Yes. So at least in the case of IAT, there is certain tools that are jointly used, and I think VTT over the years has taken steps to ensure the proper use of the tools, either by having a VTT operator or even for the companies, or by having very strict rules and training how you use the tools. So there is certain tools that are shared, but then in the case of IAT, for example, there is certain tools and facility that we invested heavily and nobody touches. So once you become a company that you start producing thousands of those things per month, the answer is no, you cannot share everything. But there is tools that have a huge capacity. You have sputtering equipment that have a capacity that can fill many times over the entire global dental market with imaging devices. So this kind of equipment can be shared. There is a lot of this kind of that are also, by the way, hugely expensive. I mean, no company like Advacam, IAT, or others could afford to buy €2 million worth of sputtering or €3 million worth of lithography equipment. But then you have the specialized tools dedicated to each company. So I would answer your question is, I definitely want to see a lot more students, a lot more research here, because that's also from where you hire people in the future for the companies who will maintain their activities in the Micronova. And obviously VTT needs to close more contracts for companies to be in here and use the facility. Open.
Relating to the technology, I understand that almost everything can be done in-house here, like microcircuit design, interconnection technology, and all these things. But what about the crystal, the directly converting crystal? That is something that is like a bottleneck when it comes to resources. So would it make sense, for example, with this new mercury iodide, to start an effort of actually making it here in Finland?
Okay, this question is also, you like to ask politically sensitive questions. I mean, also before you asked me not to reinvent the wheel, it has taken Akrad, which is a very close partner of Ayat, a very close partner of mine. It has taken them 20 years to make the material the best in the planet and the cheapest in the planet, cadmium telluride, which is done in Okinawa. To make cadmium telluride in Finland, honestly speaking, it would be suicidal. Number one, you would have to spend millions upon millions, and then 10 years later, you would be at the level Akrad was 10 years ago. Number two, you will immediately lose that wonderful relationship. Whatever we do, we must respect the relationships we have and find our added value to the value chain. Not try to copy, not try to reverse engineer others, but come with our own unique ideas and benefit from what is available. The mercuric iodide is not yet in production, but then you have to decide. Do you have a partner somewhere, maybe in the United States, maybe in Japan, who makes the material already mature enough and you want to work with them, or you step on their foot and start doing it here? So my answer to your question is that no. In my plan, I'm not planning to bring the material production in Finland. I'm planning to bring everything else, the assembly, the electronics, the software, like we have been doing in the past. Okay, I think Philip is running out of time, but...
Well, I have all the time in the world to listen to that. We have another question maybe here.
Konstantinos, you have a proposition for government how to change this innovation fund in climate in Finland. Do you have an idea how to deliver this proposition, how to influence Finnish government, how to approach them, like this changing with Sucess, which quite dramatic, and university and a lot of others? Thank you.
So what is the ministry that decides the budgets for VTT and Sucess? It's the Ministry of Energy. So what my proposition would be, you get me and a bunch of other CEOs from other high-tech Finnish companies. We go to the ministry, we give a presentation and we tell them, stop that ridiculous, non-sustainable socialistic welfare system and rechannel the money back to the high technology and the innovation. Keep the budget of organizations like VTT and Sucess to the, I mean, that's the only, to make noise, to actually, and if somebody invites me to go to the ministry, what you heard today is nothing. I will say a lot more than that.
You can also share the link to this video when it's on YouTube at that time. Other questions?
Okay.
This might be a nasty question, but since I see a lot of Ayat people here, so I was wondering, it seems that you are aiming actually the same market where Ayat is currently. So do you consider Ayat as your future competitor?
I consider Ayat, X-Counter, Advacam, Dalsa, Hamamatsu, Rayens, E2V, Varian as my future competitors and my future partners. It's up to them and me to decide which one it's going to be.
Good question. Okay, a last question. No last question. Maybe a comment from me. Then I think about productivity. I think productivity is a lot depending on culture for the same labor cost, and I believe that under your management, culture might increase the productivity. So thank you, Konstantinos.
Thank you, everyone.
Bye.